Hello, welcome back. In this video, we will understand the creation of Numpy arrays and some important attributes of n-dimensional array, that is ndarray object. It's exciting, right? So let's get started. So we have understood the difference between Numpy array and list. We have also seen the amount of time taken for execution for Numpy arrays is pretty much less when compared with list, right? And we have also seen how does the arrays when you declare with the help of module or when you declare with numpy array, and what is the main difference when you are seeing, right? Because you need to mention the type code when you declare with import array, but in numpy arrays you need not do it, right? So that is how we have seen some simple difference when you're working on numpy arrays and with the help of the array module. Now let's try to understand the different ways of creating numpy arrays, that is n-dimensional arrays. First, let's start with the basic list or the basic tuple, or whatever you take, list of lists or whatever it is. So first let me try to give arr is equal to, I am pretty much comfortable in writing arr. You can give any of the variable name. So np dot array. So np dot array of, it will throw you the basic thing. So when I just try to give np dot array of whatever you try to give, suppose if I try to give the list of values 1 4 2 5 6, see, it is throwing you an array, any object exposing the array interface. D type is the desired data type, copy and order, the specified order need not follow, right? So you need not worry about all the methods in it. Python will directly take care of it. When you print this arr, it is an array of, it's basically one dimension where we get the shape, size, and we have so many things. It depends on how it is storing with, you treat that as a matrix. In your view, you'd imagine it as a matrix with rows and columns. It would be easier, and how it is being stored when you just compare with the one-dimensional arrays and n-dimensional. Because the best way to think about numpy arrays is they consist of two parts. For a data buffer, which is just a block of raw elements, and a view which describes how to interpret the buffer, because the generic way of storing elements, right? So that is the way you just try to understand. Let's make it very simple. Suppose if I just try to go with this, like if I go for arr dot, because it is an array, so you can see all the things. If I go for arr dot d type, suppose if I just execute this, it is of integer type, because if I could throw anything in this 1 point, that will become obviously float, because we have just converted that thing into float, right? In that way we have some basic functionalities over it. First, let's try to declare a basic list or tuple, then we'll try to understand. So first let me take a tuple, a is equal to 1 4 2 5 6 or whatever it is. You need not take the same elements. By coincidence I got the same elements, it's fine. So now what I'll do is I'll try to convert that thing to an array. np dot array of, it can take any object, right? Why can't it take a tuple over there? Because till now a is a tuple. You can just make sure you give print of type of a, and I'll just keep the third line as comment. So you obviously get the result as class tuple. But now what I'll try to do is I am trying to convert the given object into an array, np dot array of a. So that becomes an one-dimensional object. That means when you go for, let me try to throw this to a variable like b is equal to, or let me just make it, so b is equal to np dot array of a and b dot, you can just get some functions over it. When you go for b dot n dimension, because it generally defines the dimension, it is one dimension, because it's a tuple object over there, right? So you need not worry about it. How do I convert, how do I create n-dimensional objects over there? Where can we give a list of lists within it? Suppose I try to give 1 2 3, that's where you are given list of objects, right? 1 2 3 is a list, and 4 5 6 is another list, and 7 8 9 is another list. That means, because the main difference between one dimensional and two dimensional would be, as I clearly mentioned, whenever you see an array, basically think of it as a two parts. It is the buffer, how it is being stored, and the view, how do you represent that buffer, right? Because array, it's of same type. You just see box It's something like a train, each compartment. In that way you think it is very much easier, because it generally when we go for accessing the index, it would be different, because it starts at indexing starts at 0 and ends at n minus 1. The same way, when you try to change the shape of it, we'll understand it. So just need not worry. So now I have defined a list of lists here. Now what I'll do is, I'll try to convert this thing to an array. So np dot array of A, now it is not a list, but it is transformed into n-dimensional, where it is having 3 rows and 3 columns when you just interpret in that way, right? Yes, so that is how we could understand, how we could transform, whether you gave list of lists, or let me try to prove it. What happens if I give something like C is equal to np dot array of A and C dot n dimension, because n dim will give you the dimension. So sorry, it's not C, right? So C is equal to np dot array of A. I just need to rerun the cell. That is the reason it gave me a name error, because when you see name error, that is not different. It is two-dimensional object, because n dim will give you the dimension of it. Whether you take the same thing with tuples also, you get the same result. You need not worry whether it is a list of lists or tuples of lists. What I'll do is, I'll just try to copy the same thing and replace the square braces with parentheses. That becomes a tuple, right? So that means you can define the multidimensional arrays by replacing those square braces. So I'll just replace this square braces where I'm giving tuples inside a tuple. So this is my nested tuple. You could think in that way. That means that is how we create an n-dimensional array. I'll just show you the same, because now we are converting the given object into an array. So np dot array of A, again I would just try to throw, you could see the same result. See the same result which we have seen earlier. So that is how you have created an n-dimensional array. That means generally you create in this way. A is equal to np dot array of, suppose you want to give multi-dimension, just start with the square bracket, that is you pass list of values 1, 2, 3, comma 4, 5, 6. So that is how you just throw it. The same way which I have written earlier by directly giving list. So the dimension, the shape would be 2 by 3, where you have 2 rows and 3 columns. That means now if I try to throw the default things, that means if I try to take this tuple, so if I just try to give this variable as E, where I would just try to convert that tuples by taking the functions which are present in an array, right? So I would give np dot array of, my input object would be E, because I have defined E is my tuple. So tuples of tuple. So E comma, where we can take the D type is none, where I would like to throw my D type is equal to, the data type is equal to, I can take anything. Suppose if I want to take float object, np dot, where if I want to take the float object, I could take whether, so it depends on our interest, how do we try to take. So when we execute this, you could see it is converting that thing to a float. So that is how you have understood how do you create array from list of lists or tuples inside a tuple, whatever it is, it's up to you. Now let's try to understand some attributes within it by defining an array and checking the shape, size, item size. These are very, very important attributes when you go for working on an array. So for that purpose, I would like to create an array by manually. It's not by taking anything. So always when you go for creating an array, make sure if you are going for multi-dimension, that means you go for creating lists inside it. So I'll go for 1, 4, 5, and because it's always square braces only, there is nothing hidden with that. So I would like to define, with something like 3 by 3. That is the reason I'm defining 3 lists inside it. So when I go for print A, or I call the variable A, you get, see, this square brace is mentioning these are the 3 lists inside it, you imagine, but it is defining in the format of an array, right? Because when you go for type of A, it will throw you basically n-dimensional array. Or when you go for A dot D type, that will give you the data type of that specific array. This is integer, where we are having only integers within it, right? In the same way, I could go for checking the shape of it, because when I go for shape within it, it will throw me what is the shape of an array, because we are having in this 3 rows and 3 columns when you treat that as a matrix. But basically you could see this is 3 by 3. Similarly, when we go for pandas, we convert this array format into tabular data. That's where we go for data frame and series. So just make sure shape will give you the shape of an array, and a dot size. When you go for a dot size, it will throw you the amount of, or sorry, item size will throw you the amount of memory. Size will give you the number of elements. Number of elements in an array. Size will give you the number of elements in an array. That's what we have seen when we have gone for comparison of time. If you could just throw your light onto the previous videos, that's what we have given. When we have gone for checking the memory, it is size, right? Size will give you the number of elements in an array. Then when you go for item size, it will throw you the amount of memory, how much amount of memory is being occupied. So size is different, item size. So item size will throw you the memory. So size will give you the number of elements of an array. Shape will give, you can just write it as the length of an object. So length of an object, length of array object. Length of array object in the sense that is memory point of view. So size will give you the number of elements in it, and shape will give you the shape of an array. So this is very, very important when you are going for checking attributes within an array. These are very simple attributes. And even when you are going for dimension, a dot, when you give a dot in dimension, it is a 2-dimensional array. So these are all basic attributes when you work in an array. That's how we have understood the different ways of creating array within a list of lists, tuples inside a tuple, whatever it is, we have understood the main thing. And even you can also go for another simple way where we can use a simple function called as array. That means suppose if you could take a list or arrays in something like this, a is equal to a list inside a tuple. You can also have that thing, right? So 1, 2, 3. Suppose I'll take some values in it. Now what I'll do is I'll try to use a function called as array, not array. If I go for as array, I'm just representing that as an array, np.asArray of a, and now see it is giving return a data type and everything it is giving you, right? Because you did not call the variable directly. So when you print the variable, you could see the difference where how does that is being stored. It is list of and 45. Now let me try to define the same thing with array. You could find the difference. So when I define np.array of a and I'll throw it as b. See, so array of list d type Python object. See, it is giving some depreciation warning. See, creating an n-dimensional array from ragged nested sequence with a different length is depreciated. So you need not worry. That is the reason you could also use array of conversion. So you need not worry about it. Array will make you sure that you can convert that thing into an array format. That is how we have understood, because it is being depreciated in this particular version in the sense that we need not use it. You already know how to convert that thing by taking tuples inside a tuple or lists inside a list by giving np.array of a, whatever your type is, that is multi-dimensional. That's what we'll be working on it. So you need not worry about this, because this is where some kind of depreciation warning. So you can also use np.asArray, or that is general things when you try to explore yourself. So you could work on the different things and make sure how does the Numpy arrays are being differing with lists. So array is another kind of function where you try to just make sure you understand the insights in it. To make it more simple, why can't I go for converting anything like this, right? So what I'll do is I'll just try to take an array like this, which we have already taken. I'll try to take these tuples again, and what can I use in array? I'll just throw some light on it so that it will be easier for you. So I'm just taking this tuple again. So I'm just taking this tuple not as a single list and values. I'm taking multiple tuples. I would not get warning here. That's what I would like to throw light on you, so you could find it very relevant. So I just give arr is equal to np dot array of e comma, and I could mention my n dimension so that I could convert that thing into 3 by 3 format, right? So that is nothing but, I mean, generally when I give n dimensional, what do you mean by n dimensional here? It is mainly telling you the number of dimensions, right? So what I would like to throw is, I would just give arr so that you could see that thing with the help of, sorry, n dimension. I think I gave the name as wrong. So np dot array of d min, not, I mean, it's, I gave n d min, so n dimension n d min. I just gave n dim. Just make sure that syntactically you are correct. So again I gave equal to symbol, my bad. I just gave n dimensional, right? Good. Now you can convert this thing by giving like arr dot, you can also use as type, right? As we can mention as type, you can convert that thing, copy of the array cast to a specified type. As array is different and here as type. That's what I would like to show you, the main difference when you can try to typecast into another format. Suppose it can be of string. Suppose if you would like to convert that thing to string, there you go. That will be converted to string format. And even if you want to give that thing to float, you are good to go. You could throw that thing as float. So you can see everything in float format and data type. That's what I mentioned. U, F, I, integer formats, type code formats. That's how we have understood the different ways of creating arrays and checking the attributes within it. So D type will mention type of it, shape will give you the shape of an array, size will give you the number of elements, item size will give you the length of array object, whether it is integer, float, complex. This is how we have understood. So as array has been depreciated, you just start working on it, you'll understand. As type you can convert to any other type. So in the next video, we will understand the basic concept of indexing and slicing. Then we'll go for the concept of Boolean indexing. We'll go on working on some more operations over Numpy array. So in this video, we have understood different ways of creating Numpy arrays and important attributes of n-dimensional array. In the following video, we will know about indexing and slicing. Thank you. I hope you have enjoyed watching it. If you have liked our content, please do hit like button and do subscribe to our YouTube channel for more useful content and exciting updates. If you want to learn such practical content at an affordable cost with Microsoft certification and instructor support, please register at academy.codegnan.com. You can also download app from Play Store as Codegnan. Never hesitate to raise queries in the comment section, and please do reply with your suggestions for more practical videos. We'll be happy to come up with it. Thank you.